The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to the Srijan Wednesday webinars. For those of you who are joining us for the first time, this is a community initiative by Srijan Technologies, where you can tune into a variety of sessions across the fields of technology, entrepreneurship, and community building. In today's session, we are joined by Vivek Singhal, co-founder at CellStrat. Today, Vivek will take us through the disruption being caused by AI and machine learning across industries and how businesses can leverage this. We will also take a closer look at the concepts of regression, classification, and neural networks. Before we begin, I would request all participants to please type in any questions that you have during the presentation, and we will take them up in the last 15 minutes of this session. Also, please don't forget to take the conversation live on Twitter using our hashtag SrijanWW. Now that that's over, let's get right to it. Vivek, over to you.
Hi, thanks for this event today. Thanks to Srijan for organizing this event. I hope you all can hear me clearly. My name is Vivek Singhal. I'm a co-founder and data scientist at CellStrat. So I'll be discussing about artificial intelligence and how it's impacting business today globally, and what we can expect from this technology going forward. Okay, so let me get started here. So just a plug on my startup to set up context here. I run CellStrat, which is AI startup in India, and we are working on multiple machine learning innovations and solutions. We produce a lot of research in artificial intelligence, machine learning, and deep learning, and we support solution development, product development, and content development for different educational companies. Okay. We keep going. So we are interested in areas like e-publishing, marketing automation, text recognition, computer vision. So I think the broad array of vertical industries are now facing disruption by artificial intelligence and machine learning. I think I could go on a limb and say there isn't any industry which won't be disrupted by AI going forward. Okay, and it's a relatively newer area which has broken out in the domain. It was limited to universities before, but now it's gaining mainstream attention in commercial sector. We in CellStrat, we are focused on algorithmic design, things like probability modeling, regression, supervised, unsupervised learning, neural network, some of which we'll talk about today. Then we also do solution development in Python and Google TensorFlow, which are the sort of a popular development stack for machine learning. And we are all familiar with Amazon Alexa AI service, which is rendered through its Echo chatbot, which is a best-selling device, particularly in the US, for chat-based applications. We do produce a lot of content in AI and the ML space, which you can see on our website at that link. And we are doing a talk series similar to this webinar all across India and over through the internet for global audience. So let's talk about artificial intelligence, and what's happening with this new area. So Andrew Ng is a very popular data scientist. He was until recently the chief data scientist at Baidu, and before that he was head of Google AI division. He is a professor at Stanford University in California, and he has said this statement: AI is the new electricity. So just as electricity changed the whole world and it became so essential to human existence, so we are expecting that artificial intelligence will don the same stature, and we see that happening with daily news cycles around AI and its applications. So let's look at the business of AI. What are some of the areas which AI is impacting? So let's talk about where we were and where we are going. So you see, we have had the industrial revolutions in our recent history of the world, and we started with Industry 1.0, then we went to Industry 2.0, then as of late 1900s, we in early 2000 we had Industry 3.0, and we got into computer science, internet, and electronics and automated production, supply chain, and so on. And now we are in Industry 4.0 era. So we call it the fourth industrial revolution, which is the commonly used term for this era. And in this era, we see connected devices and connected age blurring the lines between physical, digital, and biological spheres, and personalizing everything to consumers and businesses. So whether you use an Apple Siri or Amazon Alexa chatbot, it is learning from your speech, it's learning from your business behavior, and it is offering you personalized services and applications. Okay. So in the last few years, we see a connected era in fourth industrial revolution, and some of the common technologies here we hear about are in this era are IoT, connected devices, artificial intelligence, blockchain, virtual reality, augmented reality, and so on. So it's a very exciting time, and we see huge technological disruption. So let's get some perspective. What is what was happening before, and why we are where we are with artificial intelligence. So you see, we had recently a phenomena of big data, and the word big data became very popular across the technology industry and other industries. And people have said data is the new oil, and there is a battle for ownership of data as well as deriving benefits from it. So there are companies like Google, Facebook, Amazon, which are sitting on vast reservoirs of data, and they are able to launch new services which are highly personalized for global consumers, global audience, and their market cap as well as their power in the world continues to rise. And hence, there is some fears by some quarters saying that we need to regulate some of these new companies to prevent them from becoming overly powerful. The reason they are overly powerful is because they have all the global data. Many of these companies now have data which is much more than any government of the world. So, it is, if they have malicious intent, yes, we face some trouble. So we have to see how to, balance out or democratize the new tech domain where data is concentrated in hands of few tech powers. So you can see we have 180 zettabytes of data as per 2000 by 2025, as per the research company IDC. And there is a huge amount of data, unstructured data flowing from social media, transportation, automobiles, and all kinds of sensors, whether they be biological sensors, IoT sensors, or just any kind of connected devices. Earlier, this data was very effectively used by these online companies like Facebook and Google for targeted advertising. Now it is powering the concept of artificial intelligence or cognitive services, and some of which are beginning to generate revenues for these companies. So there's a network effect which happens in data. So you can use data to attract more users, personalized services attract more users. These users generate even more data when they use your services. This helps improve the service quality. These companies can then improve the quality of their services after observing the user behavior. And and once they improve the services, this attracts even more users. So there's a network effect which goes on. So and hence we say the data centric companies like Google, Facebook, Amazon, or Twitter, they continue to gain more power, and putting rest of the companies or the world at disadvantage. So you can see the chart there. The amount of data is just proliferating, going berserk, if you will. And all the companies are now talking about artificial intelligence. So what is the connection between data and AI? So you see, AI feeds off data. AI learns from data. The way you make machines intelligent or create artificial intelligence is by training machines on this data which you have. So that's why big data is relevant in this discussion, because big data is what leads me to artificial intelligence. Okay. So just to get AI defined, what is artificial intelligence? It's a branch of computer science that creates intelligent machines that work and react like humans. So basically, we are creating machines which simulate human intelligence, if you will. And AI-based machines can use big data that businesses are collecting to identify patterns and insights more efficiently than humans can. So AI is, powering, amazing analytics and insight development. And the way you train these machines is from this big data. Another aspect which is driving the proliferation of artificial intelligence now is the availability of cheap computers from the likes of NVIDIA and others. So, they have graphics processing unit, GPUs, which are able to put the power of AI in desktop computers. Earlier, this computing power was limited to supercomputers or mainframe servers, but now regular smartphones and desktop computers are also having these chips which can do immense computations and thus drive artificial intelligence. Some interesting examples we see and read about in the papers every day: self-driving cars. In many cities in the United States, they are testing these autonomous or self-driving cars from the likes of Uber, Google, General Motors, and so on. So in future, we see electric cars and followed by self-driving cars. And then we hear about these artificial intelligence systems which have beaten games global champions in chess and Go. So these are some interesting games, which board games, and Go is a Chinese program which is popular in the Oriental world, and chess is globally popular. And so we see AI which is now beating the world chess champion and the world Go champion. And of course, we are used to Apple Siri, Google Assistant, and Amazon Alexa or Echo chatbot. So now it is able to understand human speech and respond in human speech. So let's keep moving. A very useful application we see around artificial intelligence has to do with the financial services. For example, SDFC is one of the largest Indian private sector banks, and in the new Industrial Revolution 4.0, they have deployed these robotic assistants in some of their branches. So you can step into a branch and talk to the robot, and it will authenticate you by computer vision, by recognizing your face, and it can act like an automatic teller, and you can ask questions of it, and it will give you correct answers. So you can ask about your account balances or request other banking services. So let's look at some of the top use cases of AI. So AI, many people say, okay, AI is hot, but where is it being used? So we find that machine vehicular object detection, identification, avoidance. So basically the top line has to do with computer vision. So whether it be an autonomous car or detecting objects in images of different kinds. So that is apparently the biggest use of artificial intelligence for object detection in images or for autonomous cars. And the next one talks about classification and tagging these images, and then patient data processing or artificial intelligence for healthcare applications, automatic diagnosis through machine learning programs, deep learning programs, and trying to supplement the shortage of doctors which we face globally. Algorithmic trading in Wall Street and so on, and localization and mapping technology, and then predictive maintenance, predicting behavior or a failure of machines early on. So the applications of artificial intelligence are countless, and you can see the expected revenue from AI applications in that chart. A very interesting use case, IBM Watson. IBM is a leading player in artificial intelligence. They have this platform which they call Watson, which is AI enabled or an AI platform, and they have deployed this robot called Connie robot in the Hilton hotel in the US, in some of the branches of Hilton. It's a concierge robot. So once you walk into the hotel reception, it can guide you to your room or provide you other hospitality services. And some other examples we see for these robots are in robotic process automation, transport, security, military, and so on. So as we said, almost every area, as we know, is either already facing disruption by AI or sees disruption by AI in near future. So we find that AI has beaten world champions in the Go game, the board game Go, as well as chess. And in fact, way back in 1997, IBM supercomputer Deep Blue had beaten the Russian grandmaster Garry Kasparov and world chess champion at that time. And Kasparov has written a very emotional book about the whole concept and how he got defeated by artificial intelligence. So you can check that book out on Amazon, perhaps. Recently, Google, DeepMind team or Google Brain team has trained an artificial intelligence software to basically beat the global champion of Go. Go is a very complex game with multitude of combinations, as you can see in that image, and an AI software has now beaten that world champion in that area, which is a Korean Chinese guys. So just a summary of some interesting applications of AI and machine learning. So we see AI being used for image processing, image tagging, automatic image recognition, for example, in your Facebook photos, optical character recognition for recognizing digits, handwritten or printed digits or text, self-driving cars, text analysis for detecting spam in your emails or SMS, and checking sentiment in your Twitter feed, around different global topics, extracting useful information from text, and then data mining, detecting anomalies, for example, credit card fraud, detecting associations, for example, in a store, what products can you sell together, and so on. In healthcare, we see diagnosis and also image scans for, X-ray images and CAT scan images and so on. In cancer, oncology, for detecting cancer in a timely fashion and accurate fashion, and drug trial in pharma companies. And we also see a branch of AI called reinforcement learning for training video games and as well as autonomous cars. And then, of course, we have seen robots in many Hollywood movies, and these robots are now being deployed for industrial tasks, industrial automation, as well as human simulation. For example, a robotic teacher or robotic concierge. Okay. So, shall we learn AI? I mean, that is the question. It's such a hot area. It is one of the hottest area going forward. Yes, I mean, you can see the demand for AI talent is far, far outstripping the availability of AI talent. Right now, there's a conference called NIPS conference, as it's called, going on in California, the top AI conference in the world. It used to be an academic conference discussing some of the AI applications. Now it is flooded by all the tech behemoths who are trying to hire AI researchers in that conference and doling out huge salaries to folks who are expert in this area, because there are very few of them. CEO of Google has said that there are less than 10,000 people in the world who are expert in artificial intelligence, and the demand is for probably millions going forward. So I think it's a very fruitful exercise to train oneself in AI and develop a career in this segment. Now let's go to some of the technical aspects of artificial intelligence and machine learning. So just to open the hood and see what goes on inside. So as we said, AI is about simulating human intelligence. And then we have a branch in AI called machine learning. What machine learning is that we train machines to learn from data. So what is machine learning? It is basically machines are observing data and they learn from that data and then they become intelligent. So in that sense, machine learning is the way we enable artificial intelligence. Okay. So this is machine learning is the main way how we enable artificial intelligence. We train machines or softwares by making them observe current data and derive useful insights or patterns. Again, some applications are listed of machine learning: robotics, computer vision, image recognition, chatbots. I'll let you read it on your own. There's a huge list. So the list of applications is quite endless, actually. So some features of machine learning. So, we had analytics from before. So what's so hot about machine learning? How is it different? So far we had traditional analytics, which would rely on hard-coded rules. So if you are using, some popular software like IBM SPSS, SAS, SAS, or some others, which were designed for analytics applications, you were hard coding the rules. The data scientist or the architect would have to know what are the subject matter rules and hard code them in the program. And ML, on the other hand, relies on learning patterns based on observed data. So in machine learning, we don't hard code the rules. We feed just data into the software, and it derives the algorithms by observing that data. Okay. So there's a fine difference between traditional programming, traditional analytics, and machine learning. And AI systems learn by extracting patterns from data. So this is what we have been talking about as machine learning. So we have a set of observed data. We have input X, output Y. We have a lot of such combinations, like X comma Y, and we feed that data into our model, and our model gets trained based on this data, is able to reverse engineer the relationship between X and Y. So this is exactly what we are doing when we say we are developing a machine learning program. So ML can learn from labeled data, supervised learning, which means for every input X, I have an output Y or a ground truth, available. Unlabeled data, unsupervised learning refers to the fact I have input X but no output Y. Okay, so I just have input X but no output Y. So in supervised learning, I have X and Y. In unsupervised learning, I just have X, no Y. So one is working on labeled data, the Y is called the label, and the other set is working on unlabeled data. And the unsupervised learning is a harder problem to solve because we don't have labeled data to train it on. We can still do something interesting with it, but not all the things we can do with supervised learning. We'll see some of the capabilities of these a bit later. Now, computers can take decisions that appear subjective. So an ML algorithm called logistic regression, which is used for classification, can determine when to recommend cesarean delivery, for example, in a maternity hospital. Okay, and there is also naive Bayes, which can detect email spam and so on. Okay, let's keep moving. So a lot of people are confused. What is the difference between deep learning, machine learning, artificial intelligence? Let's just get that out of the way. Artificial intelligence is a broad concept, right? The outer circle which you see there, and that is a broad concept of making machines intelligent or artificial intelligence. Then within that we have machine learning, where we have these set of algorithms by which we train these machines to make them AI enabled. Then within that we have something called representation learning or discovering the hidden data patterns. And the newest and the most interesting area which has come up recently is deep learning. So in deep learning, we are able to do more complex tasks. For example, image recognition, speech recognition, text analytics, and so on. Okay. So these are sort of the differences between deep learning, machine learning, and AI. So let's look at that through a diagram. So in the old days, what used to happen, we'll have a problem statement. We as developers or scientists have a problem to solve, and we code the rules in the software code using Java or PHP or whatever it is we are using. And then we'll check the results of our program. If it passes the test, the unit test and the regression test, we typically put the program in production. And if it fails the testing process, we will review for errors and go back to problem definition and try to debug the program. Okay. Now in the new world, on the other end, what happens? So the process looks pretty similar, except in the middle, instead of hard coding the rules, we are feeding training data. We are feeding lots of x1, y1, x2, y2, x3, y3 kind of data, and we are having the program learn the relationship between x and y by observing this data. So then once we have gone through the training step, once we have a trained algorithm, then we test it using test data, and if it during the evaluation phase, if it passes, we put it in production. If it fails, then we go send it for review again. Okay. So how does a regular program work? We have input data, and we have code, and then we have an output, right? So we have some data, we have programmed the code, which has a set of steps, and it produces output. In machine learning, works differently, as we already said. So we have input data, we have the output also supplied to us. So that output in the first row there is called the label. So this is called labeled data. And then we have the training code, the software code in whatever language we choose. And then from this, we derive the parameters, or we learn the parameters of the equation. Okay, the equation being something like y is equal to 5x plus 7. So I'm trying to learn what is the y is equal to mx plus b. I'm trying to learn the value of m and b in that equation. Those are called the parameters. An evaluation step would be when I use the learned parameters and I test it on test data, and I compare the output predicted with the known output. So since it's a supervised learning case, I know the output and I can compare it with predicted output. So I compare predicted output of the algorithm with the known output. If there is no difference, that means my algorithm has passed the testing phase. I can put it in production. If the predicted output does not match the known output during testing phase, I have to retrain the model. Okay. Now let's look at some important machine learning use cases. Okay, where all it is used. So this is so what is the difference between machine learning and data science? So data science is an area which deals with studying data and deriving useful information from data, right? So that's what we call as data science. So it has been an area which has been there, and now machine learning is works hand in hand with data science. It uses a lot of the same methods or algorithms, and so they are related, but they are not exactly same. So data science is a broader term which applies to data analytics or discovery about data, and machine learning is how we use data to train machines and derive useful algorithms. So statistical machine learning uses the same maths as data science. So these are quite mathematical in nature, all these algorithms. Uh, yeah, but obviously it has its own algorithms that get better on its own. So it's doing incremental learning. It's constantly learning from new data and making the algorithm even more and more accurate or intelligent. So machine learning is said to facilitate AI as it makes machines learn from data. So in that sense, machine learning is what connects AI with data science. So there is a fine nuance of a difference between machine learning and data science. Now, what are the major uses of machine learning? So these are the similar things we find in data science world, but now we are doing it through machine learning. So one of the key things we want to do is classify or categorize stuff, right? So for example, we are giving an email. We want to classify it as good email or spam email. Or we are given a set of patient database. We want to classify patients into different categories. This is a high risk patient. This is a low risk patient, and so on. Who's likely to get diabetes, and who's going to get a heart attack. So that is called classification or categorization of data, A, B, or C class. So you can have n number of classes in this data, and you want to find those classes. So that is one major class of machine learning algorithms. The second is predicting a trend, how much or how many. For example, predicting the prices of house, in New York. So what will be the price of house next year? Can we develop a fitment line or a trend based on past, house prices? So we'll be observing past house prices and their movements in the New York area, and compare it with the parameters which influence house prices. For example, school district, proximity to major city centers, and so on. And so there'll be a couple of variables, input factors. For example, school district, or how far is it from the city, access to the transportation systems. These will be the input features or parameters, as we call them. The output would be the price of the house. So we are trying to develop a pattern or trend analysis. And once we have a trained model, then we can use that to predict future house prices in New York. So this is answering the question, how much? Whereas the previous set of algorithms, classify was answering the question, what class? Trend analysis, or this is how much. This trend analysis is also called regression. So we use the term regression, and we have a set of algorithms under regression. And let me see, I think I have okay. All right, let me just continue. Okay, so anomaly detection. So we are trying to find, for example, odd man out. For example, in a population, can we detect, criminals, or can we detect credit card transactions which are fraudulent, or banking transactions which are fraudulent? Can we detect, financial transactions which don't meet the pattern, and so on? So this has to do with anomaly detection. There are a set of algorithms we can apply here, and then how data is organized. For example, when this is typically when I don't have labeled data, I have unsupervised learning data or non-labeled data. So I have input X but no output Y for that X. So I can still do certain things. For example, I can find groups. I can find people who are likely to buy my products from a set of customers. I can find books which a customer is likely to buy in an e-commerce domain, and so on. So I can find clusters, as we call them. So this is called clustering, how data is organized. and then we can also decide on future action. So that has to do with reinforcement learning. So let's say I'm training a driverless car model or training a video game. So what should it do next? So I use something called reinforcement learning. So that has to do with deciding on future action based on the rewards I give it. So in reinforcement learning, I give the model certain rewards, and it learns that by doing this set of actions, I will get certain rewards. Okay, so then it tends to repeat those kind of actions. So that is the final category there. Okay, so in the latest and greatest word, we are looking at neural networks and deep learning. So why is this area, sort of gaining ground? So earlier, complex tasks like image processing, speech recognition, or text recognition were hard problems to solve with classic machine learning. But now we have neural networks, which were, invented in last few decades, but just breaking out now because we have this immense computing power. So there are scientists like Geoffrey Hinton, who is associated with University of Toronto, a professor there, and also with the Google AI team, and they have written many books on neural networks. So you can see a neural network here on the right side. So the way this works is that I take an image, and each pixel is called a feature of that image. So in image is the input X, and each pixel is called a feature, or it is basically the X value. So pixel set of pixels is the X value. And each pixel, what can it have? It can have RGB value, right? Red, green, blue. So it can have three values of RGB. So basically, how I do a person or object detection in this image, the first layer checks the edges or finds the edges, right? The second layer finds the corners or contours, or where things meet, right? The corners of things. The third layer finds parts, for example, eye, nose, ear. In case of a car, it will find a tire, or a windshield, and so on. And then finally, it outputs the class of that object, which is shown in the image, whether it's a car or a person or animal. So this kind of neural network is used for object detection or object identification, and it is able to classify whether the object given in the image is a car, person, or animal. And basically, it's a divide and conquer mechanism. So different neural network layers add in little bit more value as it goes through from bottom to the top. Okay, and so what is some additional aspects here? So the hidden layers basically are increasingly, detecting more abstract features. So it starts with detecting edges, but then it goes on to detect corners or contours. Then it detects entire, objects, for example, eye, nose, tire, and so on. So this is how it breaks and it divides and conquers the problem. And we can use these kind of neural networks for speech recognition or image processing and so on. So some of the more complex programs are done via neural networks. And this branch of AI is called deep learning, which is basically a more advanced form of machine learning. Okay. So just to summarize what we said so far. So we get input X and we get output Y, and we are trying to reverse engineer the relationship between X and Y. Let's assume it follows this pattern: Y is equal to some function of X. And once we have this trained algorithm, we deploy it in production. And for any new input X new, we are able to predict the output. So this is all what we are doing in artificial intelligence machine learning process, or even deep learning. We are training or basically reverse engineering the relationship between input and output, and then we are using that algorithm to predict future outputs. Okay. So let's look at some other aspects of machine learning. Why is it so hard? Some of the things which make it hard. So viewpoint difference. You see, this is the image of a cat. Now, for humans, it's very easy to understand it's an image of a cat. But for machines, for machine learning programs, this is a hard problem because it depends on the angle. If I take a photo of this cat from the left or from the right, the image will look quite different to the model. So it will have to learn that whichever angle I take the photo from, it still represents a cat. So there's a viewpoint difference. So humans are still most intelligent, entities in the world. So we are able to detect it's a cat, whichever angle it is on. For machine, you have to train it. You can't just assume that if it is trained on the frontal image, it will work from the side as well. Okay, for detecting cat in that image. This is one more situation where things can get messy. Illumination. So, when we take photos, different levels of lighting. So in all the four photos, there are cats, you see. So for humans, it's relatively easy to identify these are all having cats. But for a machine learning program, this can be a real, a problem because it is unable to understand the lighting difference, and you have to somehow massage your model or manipulate your model in such a way that it is able to eliminate the lighting difference. So elimination can make a difference. So we are using the image processing as a way of showing some of the problems we face in machine learning programs. Deformation. Again, you can see the cat is shown in different shapes here. Again, for human brain, we can immediately recognize it's a cat, but for a machine learning model, this can make all the difference and it may get confused. So you have to train a machine learning models with variety of images. That's why we say we need lots of kinds of data. We want to ideally cover all kinds of images which we are likely to encounter in production and train the model with all kinds of images. If you don't give it all kinds of images, the model will not be able to perform well in production when it sees some newer deformities or illumination differences and so on. Occlusion. So this shows that a cat could be hidden. So again, humans can pretty much tell in all three images there is a cat involved. But for machine, it is being obscured by these obstructions. So again, you have to train a model which is trained on all of these kinds of images if you want that model to be able to perform on all these kind of images in production. Again, class of variation. You see, even though you may train a program with an image of a cat, but there are so many kinds of cats. So will it be able to perform on different classes of cat? So so as you can see, by using this image processor as an example, we have identified some problems which machine learning faces. Okay. Again, some textual, machine learning. So we are trying to train a machine on text analytics or text recognition. Now, or in this case, we are trying to derive intent of this text. So some user has written this review for a movie. The movie has great location, wonderful songs, intelligence dialogues. Though I care less. You see, so there is a human contradiction. Now, the model is likely to get confused. The first line is very positive about the movie, about its location, songs, and dialogues. But finally, the user goes on to say, I don't care. So you see, he gave a bad review, but the machine may get confused and may think it's a good review based on the first line. So there is a human contradiction or contrary, comment is there. So we have to train the model appropriately so it can understand the contrarian view here. Another example, scientists study whales from space. So if I'm trying to classify this program, is it about sea animals or sea life, or is it about space program? So humans can probably say, okay, it's about a scientist in space, but the machine may think it's about sea life, about whales primarily. So a topic classification for this statement can be confusing. So we have to deal with these topics when we are designing machine learning programs. Another one here, boy paralyzed after tumor fights back to gain black belt. Now, machine learning may think that the boy is paralyzed with tumor, but here we have a positive connotation. The user who wrote this, the author, had a positive connotation that in spite of the tumor, the boy was able to gain black belt. So he was trying to convey a positive image about it, but the machine may get confused and just associate that boy with the tumor part of it and not understand the positive, messaging. So you can check out this movie Ex Machina. It deals with Turing test. So Alan Turing was a famous scientist, I believe, in times of World War II. So there's a Turing test. The test is, can you detect a human from a robot? So in this movie, they have this person interact with this female robot, and they see the reaction of this engineer, and can he think it's a robot or it's a human. So this is called a Turing test. It's a very interesting movie, and in this movie what happens in the end, that this robot is being dismantled for the next version. uh, but the robot now has developed human like feeling, and it wants to survive and not get dismantled. So does it make it more human? So isn't the will to survive more human? So you see, going forward, we face singularity where the boundary line between humans and robots is likely to diminish. And in Saudi Arabia, they have granted citizenship to some robot recently. There was made a lot of news. So you can check out this movie Ex Machina, very interesting, around AI. So that's about it for today. That was a very high-level introduction to AI and machine learning. Uh, now we are open to any questions.
Yeah, Vivek. So, first up, thank you, Vivek, for leading us through that very informative and interesting session. And of course, no discussion of AI is complete without bringing up Ex Machina and the Turing test. Of course, it's a very great movie actually to understand the concepts of AI. So, moving into the questions, first up, the question that we have here is that. Of course, a lot is being said about AI in terms of, like, you led us through what are the possible use cases of AI, and also a lot of very fantastical things are being said about AI. So realistically speaking, right now, at what point of uh, evolution of artificial intelligence are we at right now? How much of it is realistically possible, and how much of what is going around AI is just plain hype?
So yes, that's a great question. So there is a lot of hype around AI. I think the whole world is fascinated. The media is fascinated by it, a lot of venture capital investment and so on. So we have to learn to separate, reality from hype. So some things are very real. For example, they are testing autonomous cars, and they plan to launch them in selected areas in developed world, in next few years. And Uber, Google, Ford, GM are testing some driverless cars. There is a lot of AI going on in, for example, internet world, even Google search engine. So when you search something on Google, it's using machine learning, and all the searches are basically making it more and more intelligent. When you use Google Translate for translating, let's say, from English to Spanish, and Google Translate is using recurrent neural networks. So there is already a lot of AI in production. It's happening. Apple Siri, when you talk to the Apple Siri chatbot, it is using AI or machine learning. It has been trained on human speech. Amazon Echo, so it was the best-selling product over Christmas in the US, last year. Amazon Echo is a speech recognition chatbot. So there's a lot of AI in production. But yes, this idea that AI is killing humans and so on, or robots are beginning to talk to each other, I think this is quite far-fetched, and technology is not there yet. I think we are many decades away where we achieve what we call artificial general intelligence, or robots truly become as intelligent as humans. So I don't think there is any near-term danger, but there are lots of interesting applications in finance, in retail, in banking and manufacturing, which are being used already. Okay.
Okay, great. So we're already starting to have a lot of other questions from our audience as well. So the first one I would like to take up is that can we teach these intelligent machines programming languages so that they can improve themselves whenever they learn new stuff?
Sorry, can you repeat that, please?
Yeah, so the question is, can we teach these intelligent agents programming languages which would help them improve themselves as they learn new things?
Oh, absolutely. There is an area of which we have typically called DevOps, in the past, in the software development life cycle. So DevOps automation is also being done with machine learning now. So there are companies training automation of the development life cycle process. For example, automatic, code generation from requirements documents, developing test cases from requirements documents. And then, so we had automation before in the programming process, but now it's being done with artificial intelligence and machine learning. and companies like Google are working on AutoML, so where machine learning programs can produce new machine learning algorithms. I think that concept is a bit far away still, but it is being tried because there's such a shortage of data scientists. So they want to write AI programs which can produce new machine learning, on its own.
Okay, all right.
Okay.
So if the answer is yes, we can teach intelligent agents to improve themselves, then what programming languages should we be teaching these machines?
See, machine learning, there are lots of programming popular languages we use. We use Python, we use R. If you're talking about the programming language,
Hmm.
we use Python, R. There are popular platforms like Google TensorFlow, MXNet, Apache Spark. So there are a lot of platforms which are we can use any of these platforms for developing machine learning programs. As far as intelligent agents go, they are programmed. They are programmed in one of these platforms. Okay.
Hmm. Okay, all right. So the next couple of questions are around starting to learn AI. So first up, if we want to get a sort of sound foundation in AI, what are the subjects or what are the sort of information sources that we should be looking at? Where should we start off from?
Sure, sure. We get that question a lot. So there are a lot of IT professionals around the world who want to learn AI, but they need some coaching as to where to get started, what to do. So very simple answer is, one has to give oneself, 1 to 2 years to become a reasonably good data scientist. You know, so a minimum 1 to 2 years. There are short-term programs which you can do, but you have to really do a series of training and programs. There are some good websites like Coursera, Udacity, and there are lots of good books which we can find on Amazon on machine learning and deep learning. And the
Mm-hmm.
popular stacks which we can pursue are Python, scikit-learn or skikit-learn, and also TensorFlow from Google, MXNet. And the most popular one seems to be TensorFlow and Python, but you can look at other ones like deep learning for Java or MXNet or Apache Spark and develop machine learning programs. So you have to train yourself from variety of sources over a period of 1 to 2 years to become a reasonably good data scientist. But for that you have to do multitude of training. And the most ideal scenario is pursuing a 2 year master's program in machine learning from a good university or even a PhD preferably. But people who are working may find it hard, so they can do this other approach where they train themselves using these online programs, and there's some offline classes offered by certain institutes as well.
Okay, okay. So just to round that up, because there are obviously I'm getting a lot of questions around how to start studying up or training oneself in AI. So you're saying the couple of subjects or things that you should start looking at to learn is obviously data sciences, analytics, and also the programming languages like R and Python and some bit on TensorFlow, correct?
Correct. And also some grounding in maths is needed. So I suggest folks who truly want to become data scientists and not just developers,
Hmm.
they need to revise or brush up their bit of their linear algebra, just a basic level, a bit of calculus, vector and matrices and so on. So we have to bring out our high school maths book and revise some of that if we truly want to become data scientists.
Okay.
If we don't do that, then what we learn would be programming languages and not be able to become an architect or a data scientist in true sense.
Okay, okay. So obviously there's a lot of resources and material available, and obviously a lot of resources that you shared right now. So I think what would be best is that we send all our audience a follow-up mail with a complete list of all of these resources and everything that you have shared right now, so that they can go through it at their own pace and then start to have a solid grounding in AI and ML.
Sure, we can do that. We can do that.
Okay. So another question that I have is that to what extent do we see AI penetration in robotic processes automation or smart process automation?
See, this is my personal viewpoint. Not everybody may agree with this. I believe robotic process automation is a new fancy term for automation which existed for business process outsourcing perhaps before. So in my view, I don't call robotic process automation as AI. but folks who work in this area may choose to differ. It is basically just automating a workflow or a business process in BPO companies or outsourcing companies. So that was using classic automation techniques. It was, in some cases, it may involve elements of artificial intelligence or machine learning, but it is typically being done with automation tools. There are certain tools for that. So I don't call RPA as AI, but folks who are in RPA may choose to differ. So the correct thing to learn machine learning, in my view, would be to start learning regression, classification, neural networks, and by doing courses on Coursera, or reading books on this. Some very good books are there on Amazon, and so on, and Kuda City courses and so on. And you can of course attend some offline classes from some good institutes.
Okay, all right. One of the last last questions that, and I would just like to say, or our audience, if you have any more questions, now would be the time to type them in. So another question that I had is that since you have shown AI to be disrupting a lot of different industries right now, what are some of the preliminary steps that enterprises should be taking in order to be able to leverage AI or get in on the ground floor right at the moment, so that they start building out their AI strategies moving forward? So, what is the thing? What are some of the things that enterprises should be looking at right now in terms of AI?
Great, that's a great question. So you see, there are two critical barriers to artificial intelligence. One is data. The second is talent. So in data terms, I have to say, we should keep collecting structured data. So because without data, training AI will be pretty hard, or leveraging AI will be very hard. So businesses and enterprises should start looking at their data processes and make sure they are collecting all kinds of data, and preferably structured data if they can, because this data, big data which they collect will become an asset for AI applications sooner or later. And second is talent. So they have to start building an AI capability in their teams, and bring in some good data scientists who can start evaluating the current business processes and see how AI can be utilized, or how AI can improve productivity or help the business in other ways. So I would say data and talent are the two biggest things which enterprises need to focus on if they want to get in AI.
Okay, all right. I think that's about all we have for today. However, before we finish, I think if you would have any sort of rounding up thoughts for people for all sorts of people, either be they in enterprises, decision making position at enterprises, or somebody who's just starting out in the field of AI. So, what would be your sort of parting thoughts for them in order to excel or truly make use of AI in their businesses or in their careers, let's say?
Sure. So there are two things. So for people who are going to use AI or who want to use AI, customers, enterprises, or businesses, my message is that we have to get onto AI bandwagon. Competitors are definitely doing that, because AI can enable new capabilities, new applications, new insights, which can create competitive advantage or strategic advantage for companies which are doing it. Companies which don't get onto the AI bandwagon are likely to get behind and be left out, because there's a steep learning curve around AI anyway. So that was for the people who want to use AI. And for engineers and technical folks, I think we are in the greatest time ever. We have found this new area of AI, blockchain, or whatever it may be, in the fourth industrial revolution, where the demand for technical talent, technical skill set is going to skyrocket. They are paying millions of dollars for top data scientists in the Silicon Valley. So you can imagine the demand for deep tech talent. So, but yes, we have to train ourselves. We have to continually train ourselves in this area to become valuable in these emerging areas. Okay. So, but this is the greatest time to be a technical engineer or a data scientist. That's
Okay.
all.
Yeah, I think we have it all right now. And once again, thank you, Vivek, for leading us through that session, and thank you to all our audience for being such patient listeners and sending us such great questions. I just wanted to inform all our listeners that you will have a recording of the entire session, as well as Vivek's slide deck with you in your inbox by this time tomorrow. And once again, thank you all for joining us today. And that's it. We are out for today.
Thank you all.